Yeah, well, thanks so much for the introduction, and we'll just get right into it. So, I think the Southeastern United States is an especially interesting place to study adaptation. You've got a real blend of governments that serve metropolitan areas like Miami-Dade and the coast, but you've also got rural areas like the Florida Panhandle and the Outer Banks of my new home state of North Carolina. You also have areas that vary from quite wealthy to those that are wealthy but perhaps have persistent poverty, inequality, or historic inequities. One thing that's pretty commonly true across the southeastern United States, though, is that counties are pretty heavily exposed to sea level rise. So today we're going to be presenting results from an inventory of counties. We're going to look at primarily what county governments are doing. So counties, of course, in the Southeast have a lot of governance responsibilities. Often they provide city-like services. So are counties taking the lead in developing adaptive and resiliency policies, or are they falling behind? We'll look at the factors driving that. So now for the budgeting crowds, I always have to work up why sea level rise matters and get them on the same page. For y'all, I am sure that I don't really have to do that. So if we're looking here at North Carolina, and we know that by 2050, we're expecting to see about between 1 and 2 feet of sea level rise, according to the most recent projections from NOAA. These are localized to Cape Hatteras, North Carolina, which is in the Outer Banks. We'll be looking at that as an example later on in the presentation. So as seas rise between 1 and 2 feet, and between 4 and 7 by the end of the 21st century, we're going to see a lot of impacts from sea level rise. Eventually, land inundation, yes, but in the meantime, worse and more frequent flooding, coastal erosion, and the potential for saltwater intrusion into our aquifers. So we're going to be looking at how local governments are dealing with this. Local governments don't just don't have to just think about planning and zoning and all the services they do for their own communities. They also own and operate pieces of infrastructure that are critically exposed to rising seas. Roads may become flooded, may be damaged. Stormwater systems may not be able to perform at the level they're designed for. Critical buildings and other pieces of infrastructure could be threatened by rising seas. But for local policymakers, sea level rise presents a pretty uncertain future threat. So again, what we're seeing on the screen here are the most recent projections from NOAA, again for Cape Hatteras. And by 2050, we might be looking at between 1 and 2 feet. But as we go out to 2100, the level of sea rise that we're going to expect varies greatly from a low end, intermediate low to intermediate high or high end scenario. This type of uncertainty is difficult enough for us as scholars and researchers to deal with, but for local policymakers, it's twice as hard, right? They're not necessarily familiar with the science or the meaningful differences between these scenarios. So it's not tomorrow's problem. This image, kind of continuing our Outer Banks examples from Rodanth, North Carolina. That's in the Outer Banks. This is an area that's experiencing quite a lot of erosion. So today we're looking at how county governments are studying from sea level rise. We'll be presenting the results from 2 papers that Andrew, colleagues, and I published recently, looking at planning in the Southeast and Florida respectively. And then we're going to try to move on at the end of today's presentation and discuss what are the kind of common factors that are driving adaptation, whether it's politics, exposure, or finance. So, Andrew?
Thanks, Robert. So, with a significant portion of the world's population concentrated along coastlines, adaptation to sea level rise has been a relatively active area of climate research. This research has explored a diverse range of topics, especially community outreach, vulnerability analysis, collaboration, and planning practices themselves. And in particular, a great number of case studies have shed light on these topics, really providing rich context on local conditions. However, fewer studies have extended beyond metropolitan areas and looked at the quantitative evidence on what drives adaptation. And so, how are southeastern coastal counties planning for sea level rise, and what drives adaptation? And so that's where we'll be talking about what we'll be talking about today. So we began with a study of Floridian coastal counties, and then extended our analysis to the rest of the Southeast. Our data set covers all the coastal counties in North Carolina, South Carolina, Georgia, Florida, um, Alabama, Mississippi, and Louisiana. I think I got all those, Robert.
Yep.
And then from each coastal county, we collected their comprehensive plans, land use plans, county meeting minutes, financial reports, and some other public documentation we could find on the counties. And from each of the documents, we extracted statements on sea level rise. We then categorized the statement by focus area, risk type, and risk reduction tactic. And we also placed each within stages of the of a capital budgeting model that we'll show you here just in a sec. But one thing we also did when we were coding the governmental documents was we consulted a media review that we developed. So we looked at a bunch of local news articles and documentaries, and that was able to give us some confidence in coding the data, but also some explanatory context on local conditions. Thanks. So this is our adaptive risk management framework that we use to place each sea level rise policy within the capital budgeting process. And so what we did here is we blended concepts from adaptive governance and capital budgeting. And we just want to give a shout out to because our work was very much inspired by some of the work her and colleagues have done on sea level rise planning. And again, as you can see here, it blends concepts from adaptive governance and capital budgeting together, beginning with problem recognition, data generation, analysis, problem specification, and ultimately the development, selection, and implementation of options. So these are things that both the adaptive governance and capital budgeting literature talk about in terms of staged processes of how we can make decisions. And this is a way of bringing those together using the work that we's provided for all of us. And so next up, what we wanted to do is highlight a quote from Monroe County and their chief resiliency officer. And I know y'all can read faster than I can talk, and that you're reading the screen, so I won't read the quote itself. But what I wanted to emphasize here about their road prioritization project is the emphasis on all this quote unquote data gathering and modeling done before they can jump into this multi-billion-dollar implementation plan. And so, as we all know, the Keys is effectively a set of islands connected by roads and bridges, and they're all exposed to sea level rise. And this is something that's a really big deal down there, and a really interesting project that Robert's going to talk a little bit more about as we head along here. So, how far along has each county gotten within the context of our staged framework here? So this chart shows the max staged reach for each county. Counties that are further along are shaded darker. And as it indicates, there's really an eclectic mix of progress amongst the counties. A few are doing nothing at all. Some are doing a little, and others are doing a lot. And this will have implications for how we do the quantitative model here in a little bit, and Robert will talk about that. But in some ways, the results are not too surprising, right? We're not probably too surprised that we see New Orleans, South Florida, and Charleston, where I think we actually is today, are far along, and some other metropolitan areas that you may suspect have the capacity to manage sea level rise. But of course, there's exceptions to the rules, and not It doesn't follow a clear pattern. Robert, could you go to the next slide, please? So, how many counties have reached each stage? And so, as this shows, many have recognized sea level rise as a problem, which is stage one, and a lot of developed options, which is stage five. And just for perspective, and Robert, correct me if I'm wrong, but that would be just over about 60% of counties have recognized sea level rise formally in their plans in our data set.
Just about, that's right.
Yeah, yeah. So in relative terms, just over half have recognized sea level rise in their plans, and roughly the same number of developed options. But as you can see here, some of them have skipped over the intermediate stages of information gathering, and some of them have developed options, therefore, with the benefit of intensive information gathering. So they have really targeted solutions, whereas others have not developed options with the benefit of intensive information gathering. So a lot of their policies are more focused on like, hey, we got to address the hotspots we already know exist, and that's another thing that Robert's going to unpack here a little bit further on in the presentation. I think I just heard my email. I hope everybody else didn't hear that. But anyhow, here's a count of specific risk types addressed at later stages of the model, and we're showing this because it's one thing to reach a stage of the model, but it's another thing to be taking into account multiple risks at later stages of the model. And so that's why we're showing this visualization right here. And again, what it does is it shows you the count of specific risk types that counties are looking at and when they're developing their options for dealing with sea level rise. And so what we did, and it's kind of hard to see, but it'll show up here in a little bit later, is that counties that had strong information gathering, meaning they went through stages 2 and 3, that data generation and analysis, what we did is we coded them here with stars. And as you can see, the areas stated with stars tend to be darker. And so this brings us to, sort of a basic observation that at the superficial level, at least, we could say that the depth of planning is related to the intensiveness of information gathering. And that's something I feel like I've said this probably once too many times, but that's something Robert's going to unpack here further. Thanks, Robert, and I'll hand it over to you.
Yeah, so when we look at the data, there are two big patterns, or one big pattern that we see among those counties that have really started to break down the threat of sea level rise and consider their options. And that's what we see a difference in kind of the information that they're bringing to the table to start with. So our first group that I want to discuss are these skippers. So these are counties that may have made a generic policy statement saying, look, listen, I know sea level rise is a threat. It's possibly a threat for flooding. It's possibly a threat for saltwater intrusion, but they don't go into any specific detail about how those types of broad risks apply to their county. It's kind of a baseline information gathering baseline. We know sea level rise is real, it exists, but we don't actually know necessarily or haven't documented it in our plans to note the limitations of our data set, what's going on kind of at the local level. And the result from skipping data generation, skipping specific risk assessments, is the development of options that are vague. On the other hand, some counties have invested heavily into actually conducting really specific localized risk assessments, especially in South Florida, where we see the counties have since 2011 come together, produced sea level rise projections, applied those in vulnerability analysis, and have really moved forward in that way, which allows for more tractable solution development, which allows for more specific solution development. So we're talking about vague options, tractable options. What do we mean? So our data set consists of 512 policies that we gathered across these 85 counties. And so each policy was coded as being part of our 8-stage framework, whether it's just a generic policy statement, or an example of option development, prioritization, or actual implementation. But we also classified policies according to their type. So the table that I've shown on the screen has 3 columns, and those 3 columns represent the 3 main categories where we categorized the different policies we see. The first column is focus areas, and focus areas represents the general service type that a policy was developed in. So a policy could be developed for planning and zoning purposes. It could be specifically related to stormwater, or commonly it could be specifically related to water or wastewater. So within different focus areas across different service categories, we see different types of risks explored as well. So risk types refers to the kind of or the nature of that risk within the service area. For instance, risk to a road might be a risk to a specific capital asset, or a piece of stormwater infrastructure may fail to function as designed. That would be a risk to service solvency since it's not able to live up to the expectations. Finally, our final piece of categorization are the actual tactics or the actual actions that governments are using to respond to sea level rise. And we saw a lot of generic planning, a lot of generic policy statements, and a lot of kind of relatively vague long-term plans. But other governments had really stepped forward and were already implementing regulations to improve resilience in the face of sea level rise, developing adaptive infrastructure, hardening their infrastructure, and especially engaging in detailed data generation and risk assessment. So I want to give this has all been a little vague, perhaps. So I wanted to give a really direct explanation of how this works for a particular community. So our skippers, or one of our best steppers, or the area where there's been the most development of sea level rise policies would be the South Florida region. Naturally, this tends to make sense. After all, South Florida is heavily populated. Local governments in the South Florida region tend to have a fair amount of resources. Governments in South Florida are also relatively left-leaning. So if we count the specific number of tactics, so just to make that really clear, we're counting the specific number of tactics. So did the government make policy statements, engage in long-term planning, establish new regulations, generate data, so on? When we count the specific number of tactics, we get a feel for the breadth of the planning. We get a feel for whether that county is a skipper and they've kind of developed vague options, or they're a stepper and they've developed really tractable options. And what we see from this map is that, again, South Florida, New Orleans, Charleston region have really been very effective in developing or stepping through the adaptive framework and investing in a broad range of tractable options. So digging into what's been working in Southeast Florida. So Southeastern Florida governments have really been collaborative in the way that they've managed their sea level rise risks in their area. Through the Southeastern Florida Regional Climate Change Compact, Palm Beach County, Broward County, Dade County, or Miami-Dade County, and Monroe County, which is the Florida Keys, have come together to really effectively lobby the state of Florida for better adaptive policymaking. They've come together to develop model policy that they've distributed to municipalities in this area. And perhaps most importantly, the Southeastern Florida region came together to produce localized sea level rise forecasts that they've been using on updating iteratively since 2011. I think this is really notable and impressive development, since these counties work together to consult the best available science to downscale climate change, downscale sea level rise models to their area, and have used it to applied this in risk analyses of their infrastructure across the region. So it's a guiding light for governments across the area to kind of have a starting point on what expectations are for sea level rise. Having a unified set of sea level rise projections also provides kind of a baseline understanding, a base floor for counties and governments in the area to get a picture that kind of paints a policy image for policymakers across the region that they can look to and say, listen, this is an intermediate or immediate forecast under our unified sea level rise projections that we've come together and made. Among the leaders in South Florida, Broward County stands out as perhaps the strongest county for planning purposes in our data set. Broward, of the 512 counties policies we gathered across 85 counties, Broward was responsible for 85 of those specific policies. They won an award from the American Planning Association in 2014 for recognition for being a national leader in environmental policy. And when we look at Broward, they've really invested heavily in specific, the acquiring of specific data resources and specific resource risk assessments. I want to highlight two examples that I think are especially interesting. So first, Broward has partnered with USGS to expand regional groundwater monitoring wells to track and project the movement of salt water across their aquifers. So they're really considering that risk to their water supply system. But they've also put out requests for contracts or with private engineering firms to update their flood maps, our local floodplains, to consider the effect of sea level rise. They've assessed their property tax base and have generally been extraordinarily specific in identifying, well, what sea level rise actually means for their region. The next example, also from South Florida, that I want to go through is Monroe County. So Monroe County represents the Florida Keys. So we have a series of islands that are connected by highways and roads. So Monroe has 300 miles of roads, half of which might be threatened over the next 40 years if seas continue to rise at the rate they are expected to. So you can imagine, estimates show that it costs $3.5 million to raise one mile of road. They have 300 miles of roads that could be threatened. So it's a serious, substantial problem to a capital asset in Monroe County. But they're getting ahead of the perspective. They're really taking steps to scope out their risks and prioritize those projects that are most important for ensuring they have a functional transportation network. They've invested in gathering new LiDAR data updated, which they've used to inform sea level rise impacts to roads and structures. They've completed first round of sea level modeling for buildings, roads, and bridges across the county. And they're using these sea level rise risk analyses and forecasts to both in the planning, design, and permitting of their infrastructure and for their ability to establish standards and long-term standards for the evaluation of projects in their the capital improvement element of their plan. We also see Monroe taking the final steps within our staged model of adaptive governance. They've gone on to stage 7, where Monroe has really taken these risk analysis and applied them in long-term prioritization projects through their Green Keys Sustainability Action Plan. So the plan contains 5 years of implementable projects that Monroe County can sequence and prioritize for actual capital funding. And they've already gotten started. So they've implemented and begun with 2 road elevation pilot projects in Key Largo and Big Pine, and are on the planning to conduct more. So there's a lot of engineering analysis that's gone into being specific and making the risk tangible on what specific roads, so we can lead to specific selection and prioritization of projects in Monroe. Next, I want to move up the East Coast to join we in Charleston County. So Charleston County is another example that I think is really interesting because they've been very specific about upgrading their stormwater management system. So in 2015, South Carolina experienced a massive stressful storm system, which was really, really dramatic. This image associated on the slide is from the National Weather Service. And if you squint really hard, you can see the Charleston area received 160 plus inches of rain over the course of 4 days. This naturally overwhelmed the stormwater management systems, but actually provided an opportunity for Charleston to consider how it could improve its stormwater system's ability to motivate their or increase their service solvency. So they noted these big rain events, and in 2015 noted that they weren't able to handle the system. But they moved forward with creating an asset management plan, looking at the specific drainage easements and structures that weren't working so that they could identify the most impactful capital projects for improving that system. Maybe in the discussion today, we can give us some on-the-ground feedback on whether or not those investments have been made in terms of improving the stormwater management system, Charleston. So that's another element, another avenue for the development of policies, or an avenue that we can see change through histories of flooding. Finally, I want to circle back to the beginning of the presentation by moving to the Outer Banks region of North Carolina. So Cape Hatteras, I've circled, this is the Outer Banks region, and this is specifically the Outer Banks. And as you can see, that there's quite a lot of inundation that would be expected in this area during 2-foot rise scenario. So we've been discussing South Florida, populated, wealthy, exposed. We've been discussing Charleston, also populated, wealthy, exposed area. But what about an area that is rural? Hyde County only has a population of 5,000, exposed. As we can see, the circled image is of Hyde County, and we can tell that there's quite a lot of inundation expected here. But also a county that's relatively red. This county voted, only 40% of the county voted for Hillary Clinton. So we can say that's probably pretty heavily Republican. But what's interesting to me is that Hyde County is actually looking towards the science and looking to plan for sea level rise, despite the politics of the county. So they noted that if seas rise between 4 and 7 feet, that it'd be a serious problem for the county, which could experience 75% inundation. They've recognized that there is science that suggests that such rise might be possible over the next 50 to 100 years. They've also considered changing land use policies, establishing setbacks, facilitating the movement of structures, perhaps so that they might be able to retreat in the future, and considering a variety of other policies that are going to contribute to adaptation. So they're rural, red, exposed, but they're also thinking about sea level rise. So I want to move on from kind of a couple of specific examples of different counties. So what we've seen so far are some examples of how policy could develop. So maybe politics plays a role, urbanization plays a role, and maybe exposure plays a serious role, where exposure can push counties to think about sea level rise, even if they are right-leaning. So we're going to model the amount of progress that counties have made. Now, there's two things I want to point out about this map. So this is the count of tactics employed. So our dependent variable that we're going to use to predict policy progress is going to be whether a county had any policy at all related to sea level rise. And if they had at least one sea level rise policy in any kind of formal document that we found, we wanted to count up the number of distinct focus areas, risk types, and tactics, most importantly, that they were documented using. So that'll be our dependent variable, our measure of policy progress. So do politics, exposure, capacity, or a blend of all three lead to sea level rise adaptation or influence sea level rise adaptation? So looking at the research on the barriers to sea level rise adaptation, we see that politics is often mentioned as a barrier. Historically in the United States, the Democratic Party has been much more favorable towards climate science, environmental planning generally, as well as sea level rise resiliency. So first, we're going to test if counties with a higher percent of votes for Hillary Clinton were more likely to address SLR, and if they were also developing more robust policies. Second, we think that there's a rational element to play in this policy process, that exposure should motivate adaptation. After all, if you're exposed, you have more to lose, and at a certain point, with increasing nuisance flooding, if the water's at your door, you're going to have to really recognize that sea level rise is making meaningful change. People can tell this, so we think that counties with more actual physical exposure to sea level rise risks are also more likely to address sea level rise. And finally, plain and simple, financial resources always matter. Financing and the money for projects has been commonly cited as a key barrier to change. For instance, in Monroe County, they definitely are under a budget constraint. While they have some wealth, they have 300 miles of exposed roads. So we think that financial resources are going to make a county more likely to address sea level rise and also lead them to develop more robust policies. We also, of course, are considering population, prior flood damages, and baseline resiliency and social vulnerability. So we're going to model the policy process or the development of sea level rise policies, or the development of SLR policy as part of a two-part process. First, counties have to recognize sea level rise as a threat and have to start doing something or have adapted some sort of sea level rise policy to actually make substantive progress on their adaptation. So we're going to first use a logic to model whether counties do something, are doing nothing or something about sea level rise, and then we're going to use a count model to assess the number of distinct policies across counties that are at least doing something. So we're using a two-part model to predict separately what gets a county started on addressing SLR from what gets them going and developing rich, robust policies. So to measure our key variables, first, exposure. We're using Matt Hauer, who's one of our co-authors, recent projected percent of the population exposed to flooding annually by 2050 as our measure of risk. It's a really useful measure because it integrates across all various definitions of the floodplains to give an actual kind of a non-geographic based measure of flood risk that instead looks at the percent of people each year based on population projection that's going to be exposed to flooding. Second, for our measure of political orientation, we're just using a simple proxy, the percent of the vote for Hillary Clinton in the 2016 election. Clearly, left-leaning counties will go for Hillary Clinton. We're also looking at government's expenditures per capita as a rough measure of how much they're willing to spend on services and the size of their rainy day funds relative to their revenue to get a sense of how much they're saving or the amount of slack. We're also using population, the history of flooding over the last 10 years, the average flood claims per capita, and standardized social vulnerability index and baseline community resilience index, both from the University of South Carolina. So what drives sea level rise adaptation in the Southeast? So first, I've got two models here. The first is labeled logistic regression, and the second is labeled truncated Poisson. And when we look at the results of the logistic regression, we see that counties are moved to do something significantly by the percent of population exposed to flooding, so flood risk, their expenses, the amount they're actually willing to spend, log expenses per capita, and the size of their population. But the only thing that gets a county moving on addressing more focus areas, risk types, and tactics in a significant way is the percent that the population voted for Hillary Clinton. So what's the story? On one hand, counties that are exposed have relatively larger budgets and are relatively larger, more likely to do something. But what that is actually driving substantive progress appears to be, from these results, political orientation. So let's break down the relative impact of those variables. So here I've charted the percent of the population exposed to flooding annually against the probability that a county has at least addressed SLR in some of their documents. And what we see is there's a really sharp relationship as a county moves from having less than 1% of its population exposed annually to flooding by 2050 to 2%, that county moves from a 20% chance of addressing SLR to a 60% chance. So that's a really sharp relationship over the first kind of half of our data. Of course, this effect tends to trail off as the percent of the population exposed to flooding annually rises above 3, 4, 5, 6. Fundamentally, I take this to mean if you're heavily exposed to sea level rise, you are likely going to be addressing SLR. Second, there's a pretty strong relationship between a county's spending and probability of addressing SLR. So as government moves from spending 500 to 3,500, the chance that they address SLR approximately doubles. So we see a relationship between financial resources and the government is using and their capacity to address SLR. And finally, perhaps unsurprisingly, dense urban areas, places with populations above 200, 300, 400,000 are almost certain to have at least mentioned sea level rise. Of course, everything I've discussed up until this point has been about, well, what allows a county to actually take that first step and start addressing sea level rise? We can also see that there's a strong impact on politics on the policy progress made by counties. Specifically, as the vote percent of Hillary Clinton rises from 20% to 55%. This is the Southeast, so most counties are red even along the coast. So as counties' vote percent rises from 20 to 45 and up to 60%, we see a really strong impact on the number of tactics that they're using. So for counties that are at least doing something about SLR, a 1% increase in Hillary Clinton's vote percent is related to about a 0.9% increase in focus areas, 1.5% increase in risk types considered, and 2% increase in the number of tactics. This makes sense. Tactics is probably the best measure of a county's actual depth of response. So it seems that counties that are relatively left-leaning have a much stronger response for tactics. So, in conclusion, it seems that exposure contributes at least to basic adaptation in the South. So even relatively heavily right-leaning counties did seem to be able to make some policy progress, even if they are exposed, even if they are right-leaning. Left-leaning counties have a much stronger, broader set of policies that they're considering. It's likely they've been addressing the issue for longer before it became necessarily an issue of nuisance flooding in a community. These counties probably were ahead of the game. So in South Florida, for instance, they've been collaborating since the early 2000s, right? So it'll be interesting to see how these policies develop as time goes on. And I'm going to ask Andrew if you have anything you want to cut in and add before we start in for questions.
No, yeah, you obviously got into a lot of detail there. So just at a high level, what we found is that the probability of nominally addressing sea level rise is really driven by exposure, population, and spending. So those three variables are what we find drives like whether you do kind of something or nothing. And then the second stage is really driven, at least from the models we can tell of people who are addressing it. Politics seems to matter, but as we all know, there's a multitude of factors that go into planning for sea level rise. Politics is just one of them. Our data also is from 2018. Things maybe could have changed in the last few years. Maybe as some federal monies come down, there's more people planning now. But regardless, maybe some of the relationships that we have here still hold in a relative sense when we're looking at those capacity measures and how much you plan and those sorts of things. That's all I would add.
Great, thanks.